Hello friends. Today we're going to take a look at a gadget that many smart home enthusiasts have been eagerly awaiting. Various rumors about its release date have been circulating for at least the past 6 months, if not longer. We're talking about the European version of the built-in Zigbee socket from Moes, part of the Star Ring smart device series. All devices in this series, switches, dimmers, curtain controllers, logical buttons, thermostats, are made in the same design and can be combined within a shared frame. A socket was sorely missing from the lineup, and the manufacturer has finally released it. I managed to order it at an early bird discount, which is still valid at the time of this video's release, and I'm sharing everything I've learned about it with you. More details ahead, but first, as usual, please like this video. It will help others interested in smart home tech find it, and subscribe to my channel if you haven't already. Device type, built-in socket with energy monitoring. Manufacturer Moes. Model, Zigbee. Series, Star Ring. Interface, Zigbee 3.0. Operating voltage range, from 95 to 240 volts. Maximum current, 16 amps. Maximum power, 3,500 watts. Color, white, at the time of the video release, also available in dark gray. Dimensions, outer, 86 by 86 millimeters. Inner, 48 by 48 by 32.5 millimeters. The device comes in a small cardboard box designed in the Moes Star Ring series style, with an image of the socket on the front. On the back, the main technical specifications are listed, along with the color and socket type of the specific unit in the box. The package includes the socket itself, which comes with a single frame and is ready for installation, along with a manual and mounting screws. The manual is fairly comprehensive and multilingual. It also includes technical specifications, wiring instructions, and installation guidance. The device's appearance matches the design of the Star Ring series. Reviews of some devices from this series can be found on my channel and via links in the video description. By the way, similar product lines exist from other manufacturers. For example, there's also a review of a similar socket from Seed linked in the description. The backside is 48 by 48 millimeters in size and 32.5 millimeters deep. The wires connect from the back, so the depth of the wall box must accommodate this. Access to the screws is from the top, which is convenient for installation, as it makes them easy to reach with a screwdriver. There are 3 terminals: live, neutral, and ground. As I mentioned earlier, devices from the Star Ring series can be combined in a common frame, so the included frame is removable. The socket fits into a round wall box, but 2 things must be considered. The box must be deep enough, and the socket will need to be fixed directly to the wall through the angled holes on the metal frame. When using square wall boxes sized 86 by 86 millimeters, the mounting holes align perfectly and no additional work is needed. This is what the illuminated control button on the socket looks like. The light is not too bright, so it won't be disturbing in the dark. The behavior can be customized: illuminate when the socket is on, when it's off, or disable the backlight entirely. The relay operates very quietly. Pairing mode activates automatically upon first power-up or when removed from the hub. Alternatively, it can be activated manually by holding down the button. As usual, we begin the logic section with the default control system, Tuya Smart. For pairing, I use a Zigbee thread gateway, also from Moes, which in addition to Tuya is connected as a Matter bridge to Apple HomeKit, Google Home, and Home Assistant. The socket was added correctly, including the device image, which matches the actual appearance. The app immediately suggested several template automations for it, which can be useful for beginners. The plugin, aside from the snowy forest background image, is standard for this class of device. In the center of the screen is the relay control button, which changes color based on its status. Below are 4 more buttons. The first duplicates the large one, and the third opens the energy monitoring panel. Feedback is provided when the socket is turned on or off. Energy monitoring is not particularly fast, but overall it's on par with other devices in this category. The second button at the bottom of the plugin, labeled Timer, provides access to 4 types of scheduling options. Countdown sets a time interval after which the relay will switch to the opposite state. Classic Scheduler allows for scheduling on/off times by day of the week and time of day. Next is Circulation Mode. In this mode, you can define time intervals by day of the week during which the socket will alternate between on and off. The on and off durations are set separately, for example, 10 minutes on and 5 minutes off. In Random Mode, the on-off durations are generated randomly. The fourth button at the bottom of the plugin is Settings. This menu contains a log of the socket relay's on-off events. You can also configure the socket's behavior after power restoration. By default, it remembers the last state, but you can set it to always on or always off. The backlight of the control button can be configured too. By default, it works when the relay is on. The child lock disables manual control via the button. The General Settings menu is standard. Declared compatibility with Amazon Alexa and Google Home, sharing access, offline notifications, firmware version check, and device removal are all present. In automations, the socket can be used both as a trigger and as an action. In the first case, there are 7 different options available, starting with the basic one, toggling the relay state. There are also sensor-based conditions for energy monitoring, greater than, less than, or equal to a specified value, for current, in milliamps, power, or voltage. In addition, similar conditions are available for timer duration, energy consumed, changes in kilowatt hours relative to the current value. There's also the option to select various error conditions for exceeding or falling below certain energy monitoring thresholds. In the Actions section, the options are much more limited. You can turn the socket relay on, off, or toggle its state, as well as set a timer duration. In this part of the video, we'll find out whether the device works in other control systems where the gateway is connected as a Matter bridge. We'll start with Apple HomeKit. In the Home settings, I go to the Hubs and Bridges menu and select my gateway. Then I go to the Accessories section. It shows one connected device, which is our socket. In addition to Tuya Smart, it can also be controlled from HomeKit. Aside from on-off control, nothing else is available. This is due to 2 reasons. First, the gateway has not yet received the Matter 1.3 or later update, which supports energy monitoring sensors. Second, at the time of the video release, HomeKit itself does not support energy monitoring. As usual, for Zigbee devices added to the system via a Matter bridge, information about the manufacturer, model, and firmware version is minimal or completely absent. A similar situation occurs with Google Home. The socket is recognized as a simple relay with basic on-off functionality. As expected, the situation is the same with Home Assistant. This is the third system to which the gateway is connected as a Matter bridge. Let me clarify that in all systems shown so far, the socket works simultaneously. You can use Tuya automations, turn it on via Voice Assistant, and turn it off in the Home Assistant interface. And while the socket is still connected to the gateway, let's check the native Tuya integration, where it also appears. Unlike Matter, which works locally, this integration is cloud-based. However, it does provide more control entities, some of which are hidden by default. And these are not auxiliary sensors. It's energy monitoring, the key parameters for which this socket was purchased. But the important thing is they are available, and enabling them is easy. Just click on each hidden entity one by one, go to its settings, and toggle the enabled switch. After a short time, the sensors will refresh and start displaying values. Or at least, they should. Here we encounter a problem typical for this type of energy monitoring integration. Right now, the load is active, but the power shows 0. And it only updates if you open the socket's plugin in the Tuya app. Therefore, it's not possible to fully use this socket in Home Assistant through the standard cloud integration. But this isn't the only method. I'll soon show others that work flawlessly. For completeness, the integration also provides access to LED behavior settings, though only with 3 modes. The always-on option is missing. However, it is available in the native app. And the behavior after power restoration, for instance, if there's a power outage, you can choose depending on the type of load. For example, if you're monitoring a refrigerator, it's better to set it to always on. It's time to disconnect the socket from the gateway and move on to alternative usage methods. As usual, we'll start with the smart home controller, Sonoff iHost. This is the firmware version that was current at the time of testing. We connect the socket to the iHost Zigbee coordinator. This is what the device search window looks like. It persistently suggests connecting all my cameras, but I don't need that right now. What's important is that the socket was discovered. Like the vast majority of such devices with permanent power and a neutral line, the socket is a Zigbee router, as indicated by the letter R in the upper right corner of its tile. An interesting detail, Sonoff iHost suggested a firmware update. As far as I remember, this is the first time this has happened. And as a reminder, Tuya Smart didn't offer any updates. Clicking on the link opens a warning window, and the only information about the firmware is the version number, 192. Nothing more. I decided not to update it via iHost, but to check the update option in Zigbee 2 MQTT. As for device support, everything works fine. Control and energy monitoring are fully functional. Power data updates, in my observations, no less than once every 15 seconds or faster. Current value updates a bit less frequently. There are also several scheduling options available. You can set it to turn on and off at specific times and days of the week. There's a delay, or rather, a timer, a time interval after which the socket will turn on or off, and a cyclic timer for alternating on-off operations at a specified time and for a specified duration. In the General Settings menu, there are options for behavior after power restoration, enabling the child lock, and also info about the device model, ID, and manufacturer. The socket can be used in automations. This is in the If section. Here, you can set relay status and power values for conditions like greater than or equal to, or less than or equal to. And, of course, in the Then section. Here, you can only control the relay, turn it on, off, or toggle its state. I disconnect the socket from iHost. It then goes into pairing mode, and we start testing compatibility with Home Assistant's native Zigbee integration, ZHA. A USB Zigbee stick SkyConnect is used as the coordinator. I launched the device search. The socket was discovered and connected. Judging by the number of icons for device entities, compatibility here is complete. There is relay control, energy monitoring sensors, current, power, energy, and voltage. In addition, settings for the LED button, child lock, firmware, which, by the way, doesn't offer an update, power recovery behavior, and an identify button. Energy monitoring works correctly. As mentioned earlier, power updates no less than every 15 seconds. Current may update slightly less frequently. In the LED backlight settings, there are 3 options: work when the relay is on, when off, or be always disabled. And power restoration behavior settings. Here are the same 3 options discussed earlier. Finally, we move on to Zigbee 2 MQTT. The current testing version is 2.3.0. The coordinator used is a network version based on the CC2652P chip. Native support is available. There's no need to add external converters. Obviously, Moes didn't reinvent anything and used firmware from an already existing socket with similar functionality. Here's detailed device information, exactly as expected, one of the standard Tuya socket firmwares. As promised, I'll check for updates here. They're located on the OTA tab. We check, and indeed there is an update. As promised, I'm installing it. Keep in mind, especially those updating Zigbee device firmware for the first time, this is a fairly long process, as Zigbee network speed is quite limited. System messages show the installation percentage and estimated time until completion. Be patient. The firmware was updated. Honestly, I didn't notice any major changes, except that it stopped offering an update. The Exposes page. I've already talked about all these parameters, but it's worth highlighting the countdown feature, the time in seconds after which the socket switches to the opposite state. Energy monitoring works correctly. Available values include power, current, voltage, and consumed energy. Countdown works correctly. To test it, I set it to 15 seconds, and after that, the socket indeed turned off. Here I caught a moment when the power consumption data had already updated. The relay was off, showing 0 power, but the current still had a value. A few seconds later, everything normalized. Just something to be aware of, although, in automations, it's usually the power value that's used rather than current. All of these entities, via MQTT integration, also appear in Home Assistant. One more observation. Previously, some energy monitoring sensors were hidden by default, and I had to manually enable them, which I showed in my reviews. Now, they are active right from the start. Other settings include the firmware version, which shows as current, child lock, and power recovery behavior settings. During testing, I concluded that if you need to use temporary on-off in automations, then instead of a standard delay or timer, it's convenient to use this countdown feature, which operates at the Zigbee 2 MQTT level. So, the long-awaited release of the built-in Zigbee socket with energy monitoring for the Star Ring device series has finally happened. By the way, the UK version, 13 amps, was released several months earlier. Functionally, it's a fairly standard socket from the Tuya Smart ecosystem. The differences are in the design, which is suitable for use with other devices from the series, and probably one of the quietest relays I've heard. Compatibility is excellent. In all the systems tested, the socket works one way or another and can be used. For alternative systems, support is full. That's it for now. I hope the video was useful and interesting to you. I'd appreciate your likes. They help promote the channel on YouTube. And if you don't want to miss new videos, please subscribe. In the video description, I'll leave links to all mentioned resources, as well as my Telegram channels, social media, and discussion groups related to smart home topics. Feel free to join. It'll be interesting. Thanks for watching. Until next time. Peace to all.